Hi, I'm gonna go over regular polygons, mainly exterior angles, interior angles, central angles, and the regular polygons, not regular polygons. I have two pictures right here that shows when n equals 5. That shows the exterior angles, the interior angles, and the central angles. Let's get started. Before we move on, a quick note about convex and concave figures. What is convex and what is concave? This is convex on the right side. This is concave, or not convex. A figure is convex if and only if it contains the segment PQ. As you can see, it contains every single point of that segment PQ for each points P and Q contained in the figure. So if you pick any 2 points inside and you connect them, you're going to stay inside. Otherwise, it's called concave. Here it works when you are on this side, but doesn't work on this side. As you could see, you are going outside of the figure. Okay. Now, before I start and move on, just want to show you a quick view of what is exterior, interior, and central. The one on the right side shows that we have n equals 5 sides, which is called polygon, and it's regular because the sides are equal, as you could see with the tick marks. When you connect the center to the vertices, each angle right here is called the central angle. So we do have 1, 2, 3, 4, 5 central angles because each angle is facing one of the 5 sides. So we have 5 central angles. Because it's a polygon and it's a regular, we do have those angles being the same. As you can see, I have double marks on each central angle. So the central angles are equivalent, they're equal in measure in regular polygons. Not only that, there's another comment. If you add those angles, as you could see, they form a whole 360 degrees. So the sum of the central angles will add up to 360. Let's move on to the exterior and the interior. This is an interior, second one, third, fourth, fifth. If you go around this way, counterclockwise, and you extend each side of the polygon, you will end up with exterior angles. Of course, we could go the other way around and we have it on the other side. But let's just keep it in one way. So going around counterclockwise and extending each line, you will have exterior angles. This is an exterior angle, this is an exterior angle, this is an exterior angle, the fourth and the fifth in red. The inside ones are interior angles. We have 5 sides, we end up with 5 interior angles. We have 5 sides, we end up with 5 exterior angles. Also, before I move on, because it's polygon and regular polygon, those exterior angles will be equivalent, will be equal to each other, and the interior angles in green will be equal to the same amount. Here's the theorem. The theorem says, as you can see, I'm going over notes, then I'll start. I have 2 examples for you. The sum of angle measures in a convex polygon, this is a convex polygon. We have 2 parts. Part A, the sum of the measures of the exterior angles of a convex polygon is 360. So if you add 1 prime and 2 prime and 3 prime and 4 prime and 5 prime, as an example, if n equals 5, it adds up to 360. The second part says the sum of the measures of the interior angles, the one in green, 1, 2, 3, 4 in green, they are add up to n minus 2 times 180. So 2 less than the number of sides multiplied by 180. Let's see how things work with this one. For part A, notice that I'm using n equals 5 because it's so convenient to look at 5 sides instead of 10 sides or 3 sides. 3 sides is so simple. 10 sides is too much. 5 is decent. So the sum of the measures of the exterior angles of a convex polygon is 360. In case n equals 5, we are saying that 1 prime and 2 prime and 3 prime and 4 prime and 5 prime, they add up to 360. This is another figure right here that shows 1 prime, 2 prime, 3 prime, 4 prime, 5 prime. If you cut this angle, this would be a class activity. You cut it round, and you cut this angle, you cut this angle, you cut this angle, and you cut this angle, and you put them next to each other. They will form a 360 degree. Pretty much you could see that this is aligned with this, and this is aligned with 2 prime, and so on and so on. So they kind of like go around and round and round and complete a 360 degree. For part B, here's the proof. Then we're going to use it, and we're going to believe in it and use it with common sense. The sum of the measures of the interior angles of a convex polygon is n minus 2 multiplied by 180. Let's see how is that. So if you add the 1, 2, and 3, and 4, and 5 measures in green as interior angles, you're going to end up with n minus 2 times 180. In this case, it's n equals 5. So it's 5 minus 2 times 180. So since an interior angle and an exterior angle at a vertex are supplementary. Supplementary means they add up to 180. Complementary, it means they add up to 90. So the interior and the exterior, they add up to 180. We have the following. Look at 1 and 1 prime. I think they form a straight angle, which is 180 degree, because we were extending this line or this side of the polygon. So they both add up to 180. What does that mean? It means that measure of angle 1 will be 180 minus the measure of 1 prime, the exterior angle. Same thing applies for 2. The measure of angle 2 is 180 minus the measure of angle 2 prime. If we keep doing that, and it doesn't have to be 5, all the way to n sides and n polygon, we end up with measure of angle n equals 180 minus the measure of angle n prime, the exterior angle next to it. Now if you add all the left side, which is like measure of angle 1 and 2 and 3 all the way to n, that's my left side. And if we add the right side, we get 180, 180, all the way. We keep adding 180s. How many times? N times. And we subtract m1 prime, m2 prime, measure of n prime at the end. We get the following. Adding those n equations, and you don't see the n equations. I see the first, second, and the last one. But this is what I have. On the left, I get 1, 2, all the way to n. On the right side, I have 180, 180, 180. That's how many 180s do I have? N times 180. And we're going to subtract this and subtract this all the way and subtract this. So by combining them in brackets, we are subtracting all these. Now what happens is the measure of the exterior angles, 1 prime, 2 prime, 3 prime, all the way to n prime, we said earlier from part A that it's 360. So I'm going to reduce this and write 360. That's 360 inside the red brackets. Now, to simplify this, I'm going to write 360 as 2 times 180. So I have 2 times 180. Now, in this case, I have 180 here and 180 here. N times 180 minus 2 times 180. Let's take 180 out as a common factor. So 180 out as a common factor. What do I have here? Left is n. What do I have here is 2. And that should do it. That is part B. The sum of the measures of interior angles of a convex polygon, the green ones, is n minus 2. That means 2 less than the number of n multiplied by 180. Okay, now, here's part B that we just talked about. Let me convince you by showing you some figures differently. So we have the sum of the measures of interior angles of a convex polygon is 2 less than n multiplied by 180. How about if n equals 3? Let's see if it works. This is 3 sides, n equals 3, n minus 2, 3 minus 2, that's 1, 1 times 180, 180, which is true. The sum of the angles in any triangle, the interior angles in any triangle, doesn't have to be regular, is always 180. We know that. So, let's go with n equals 4. Apply the rule, n minus 2 times 180, n minus 2 times 180, that's 4 minus 2 because n is 4. In this case, 1 side, 2 sides, 3 sides, 4 sides. Simplifies to 2. 2 times 180 is 360. Yeah, if you look at it from a different angle of view, this is 90 degree, 90 degree, 90 degree, 90 degree. 4 90 degrees will give you 360. For n equals 5, which is more interesting to look at, I have n minus 2 times 180, 5 minus 2, because n is 5, which is 3. 3 times 180 is 540. Now, why I'm slowing down at 5 and showing you the triangles inside? Even the ones below, before that, this right here, it's hard to divide it or show you because it's only one. This one here, if you connect this vertex with the opposite vertex, you form 2 triangles. And every triangle from the previous slide shows that the angles add up to 180. So I do have 2 times 180. And that's convenient. For 5, if you start at this vertex and try to build triangles inside, I do have 3 triangles, as you could see. That's 3 times 180. So that's another way to remember the formula if you forgot the formula. The number of sides is 5. You will end up forming 3 triangles inside. And by adding the angles of each triangle, you'll end up with 3 times 180 or 540. Let me show you more detail about this graph. Here we go. So in this triangle, that's the angles. In the middle one, I used red for the angles. In the left one, I used black for the angles. But the interior angles are this and this and this and this and this and this. So they all add up, the pencil one, the red and the black, to form the sum of the interior angles. Differently, it's 3 times 180. 3 triangles times 180. And 3 is 2 less than 5. When n equals 6, it does work. You have 4 triangles. You got the concept. For n equals 7, I have 5 triangles. For n equals 8, 6 triangles. I think that should do it for convincing ourselves that the sum of the interior angles is n minus 2 times 180. Now, let's get started with the 2 problems. The first problem, I do have 12 sides polygon, regular polygon, regular polygon. If you count the sides, let's double check. 1 from the base, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I do have a regular 12 gon, that's what we call it. In general, we call it 12 gon, shown as 12 for the number of sides. So usually in general it's called n gon. Give the measures of the interior, the exterior, and the central angles. The interior, exterior, and central. Interior, exterior, and central, one by one. Let's start with part A. We want this angle. Of course, they are all equal as interior angles because it's regular. So, what did we know from the theorem? The theorem said the sum of the interior angles is n minus 2 times 180. So if you add this, and this, and this, and this all the way, you'll get n minus 2 times 180, but n is 12. So we're going to write 12 minus 2 times 180 because n is 12. Do the math. 12 minus 2 is 10. 10 times 180 is 1,800 degrees. That's a sum. But we want a single one, the measure of each interior. Since we have a regular polygon, and it's regular one more time, it's regular, all interior angles are equal. So what do? The measure of each interior angle will be, take this much and divide by 12. So divide it among all these 12 interior angles. And the answer is 150 degrees. Kind of like wide open, as you could see. Kind of confirms to see it. Because if you end up with 72, it doesn't look like 72 in the figure. Something to help. Okay, next. Let's go to part B. Part B is the exterior. The measure of each exterior angle, just like this one, to find it, we know that the sum of the exterior angles, they add up to 360. Going back to the problem. So the sum is 360, and because I do have n of them, in this case 12, I'm going to divide it evenly because they're all equal. 360 divided by 12 because n is 12, and that's 30. Each exterior angle is 30. 360 for all of them, divide by 12, you get 30. The central angle, I did not talk much about it. I did earlier, but quickly. Well, when you go around and add this angle and all the angles next to it, they form a 360 because they go all the way around to cover the whole thing. So the measure of each central angle is also 30 because you do have 12 of them and they are all equal. 360 divided by 12 is 30 again. What do you get out of this? I get that this angle and this angle, they're both the same. The exterior angle and the central angles in a regular polygon, they are equal. Here's another problem. A regular n-gon has exterior angles of measure 18 degrees. What is n? Of course, when it's kind of small like this, you expect n to be larger than 4 and 5 and so on. Part B says a regular n-gon has interior angles. Measures this much. What is n? So in both cases, we're trying to find the number of sides. Part A. A regular n-gon has exterior angles of measure 18 degrees. What is n? Let me remind you of the exterior angles. Here's the exterior angles. This is an exterior angle. But what do you know about exterior angles? They add up to 360. Going back to the problem, they add up to 360. So the sum of the exterior angles is 360. So the measure of each will be 360 divided by n. But they told me what is each. Has exterior angles of measure. So that's each. What does that mean? It means that taking the whole 360 divided by n, the answer is 18. So to do a cross multiply, to simplify that clearly, I'm going to write 18 degrees over 1. So I could do the cross multiply to solve for n. Let's do the cross multiply. We get n times 18, or 18 times n, equals 1 times 360. Divide both sides by 18. 360 divided by 18, and the answer is 20. So that is n. We have a polygon that has, degree should cancel. Typo right here, the degree should cancel. It's not 20 degree, degree and degree cancels. It's n. Number of sides will be 20 sides. Let's move on to part B. A regular n-gun has interior angles of measure 169 and 7 out of 17 degrees. What is n? So we have the interior angle. It's kind of wide open. That means n is more than 5 and 6. So the sum of the interior angles is 2 less than n multiplied by 180. So each will be the sum divided by how many interior angles we have, which comes from n. So each would be n minus 2 multiplied by 180 divided by 2. N minus 2 times 180 divided by n, I think I said by 2, divided by n is what they gave me. That's each interior angle. Let's do the cross multiply, thinking that this is like over 1 as a fraction. It's kind of hard to write over 1 with a fraction next to it. So let's do the cross multiply. We get n multiplied by this much equals n minus 2 times 180. Let's do the distributive property here. I get n times 180 and minus 2 times 180, which is minus 360. I'm going to do 2 steps in one here, moving this to the left. So I could have n's on one side. This is a constant. I'll move it to the right. That's like 2 steps in one. Now I need to solve this, but I want to solve it without calculators and without common denominator. It's not really hard. I want to show you how. Here we go. So 180 n minus 169 and 7/17 n. That will be 180 minus 169 and something more as a fraction minus 7/17 in terms of 9. How many nines? How many n's? Equals 360. So I broke it down to parts. 180 minus 169 is, this is almost 70, 170. So almost 10. Do the math, it's 11. So I have 11 minus, still I have to subtract this part, 7/17. Now to do this one more time, I don't want to do common denominator or calculators. Let me show you another trick. 11 is 10 plus 1. So I could write 10, instead of writing 1, I'm going to write 1 as 17/17. You could see how I'm going to subtract the fraction. 17/17 minus 7/17 is 10/17. That's 10 and 10/17. Look, I noticed that I didn't say plus, I said and. That's another way to say it. 10 and 10/17. Now, multiply 17 times 10, 170. Add 10, 180. To make this mixed fraction as improper fraction. So it's 180/17. Multiply both sides by the reciprocal, 17/180, to leave n alone. I get here 360 times the reciprocal, which is 17/180 degrees. 360 and 180, they both divide by 180. So we get 2 here and you get 1 here. 2 times 17 is 34. One more time, this is a typo. It's not degrees, it's the number of sides. What is n? the number of sides. So I just mentioned that in the video. It's kind of hard to re-record and rewrite notes for that. That should do it. And I'll see you in the next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.